Hi, so in this video we are going to look at the kinetic theory of gases and how they react when they are in the actual atmosphere and in other words in our own world. So looking at the first point of the kinetic theory of gases consist of very small and tiny particles. These particles in real life are very small and tiny, and in real world they have large spaces between them, and that is why they are easily compressible. That means that if you want to compress the gas, for example, if you want to bring all these particles together, for example, this particles come closer to this one, the second one comes closer to the first one, third one and the fourth one comes closer. If you want to compress them, you can easily compress them because of the empty spaces between the molecules. The second point of the kinetic theory says that all the particles of the gas are actually in random and continuous motion. It means that they actually move every time, like in every instant. They do not stop until or unless any force is applied to them. And mean free path is actually the average distance traveled when a molecule collides with another and ends up going somewhere a place random, and the average distances between that collisions is called mean free path. For example, if this single red molecule hits with this one, then this molecule goes ahead and hits with this one, and this one hits with these two, and these two actually separate. This one goes there and this one goes there. So all the total distance in these collisions is called the mean free path. The third point in the kinetic theory says that when these molecules are in continuous random motion, they hit the walls of the container. As in, just consider a case where you have in this form gases molecules hit with the walls of the container, and in that case they put pressure on the walls of the container. That pressure which is applied to the walls of the container is actually the gas pressure. And also these all of these collisions are all elastic. It means that whenever they hit the wall of the container, they do not lose their energy, and they actually move on, reflect back, and just continue their random motion. Now moving on to our fourth point, all these collisions create gas pressure. As I told you before, whenever these molecules hit the walls, they actually put the pressure on the wall of the container, and that pressure is actually the pressure of the gas. The fifth point in the kinetic molecular theory says that there are no attractive or repulsive forces between molecules. It means that these molecules don't have any attractive or repulsive force, which means that they can actually act independently. For example, this molecule cannot attract this one, and also it cannot repulse it. For example, if both of them would come closer, they cannot repulse themselves, which means that they can act independently. They can collide with each other, they can collide with anything which is around their atmosphere. Now the last and the sixth point of the kinetic theory, it says that kinetic energy of the gas depends on the temperature. For example, the kinetic energy of this molecule is 16, and if the temperature increases, this the value of 16 here would also increase. It would, for example, become 21. This is actually just a random value. So the main idea here is that whatever the temperature of the gas is, the same the kinetic energy, and whenever the temperature increases, the kinetic energy of the gas also increases. Now this was all from kinetic theory of gases. In the next topic we will study about kinetic theory of liquids and kinetic theory of solids. Make sure to subscribe. Thank you.